All right, pre-calc 11, this is just a special video. It's not a mandatory one. This is just the y sine, cos, and tan of 0, 30, 45, 60, and 90 is this chart. So here's the explanation for where this comes from, so it's not just coming out of thin air. So for the 45-degree triangle, what you can do, if you don't like to memorize things and want to know why instead of just memorizing, if you did a 45, 45, 90 triangle. So if this was 45 and that was 90, this would have to be 45. This is then an isosceles triangle. These two sides are the same. If those two sides are the same, I can call them whatever the heck I want. So if I do that, then if I make this length 1 and this length 1, this by Pythagoras has to be 1 squared plus 1 squared square rooted, because that's your Pythagoras, which is root 2. Now, if I choose to, let me just see if I can keep that on there. If I sit at 45 degrees, sine of 45 is opposite 1 over hypotenuse root 2. That's where that's coming from. Cosine, same thing, sitting at 45 degrees, adjacent over hypotenuse. And tan of 45 degrees is 1 over 1, opposite over adjacent, and you get that. So that little triangle gives you 45. The 30 and 60 come from what's called your 30, 60, 90 triangle. And where that comes from is, here's the interesting piece. If I were to draw a equilateral triangle like this, no 90 in it, notice. If these were all equal, this would then, each of these angles would be 60. But what I'm going to do that's special is I'm going to cut this exactly in half, which would make this 30 and this 30. Hence that's now a 90. If I look at this top triangle now, I definitely know that's a 30, 60, 90 triangle. If I make this length 2, just because I can, this would have been 2 here as well, but I cut it in half, that's now 1. This length here then has to be 2 squared minus 1 squared square rooted, which is root 3. And now if I look at that little 30, 60, 90 triangle, I can answer all these questions. Sine of 30, opposite over hypotenuse, 1 over 2. What's cos of 30? Cos of 30 is root 3 over 2. What's tan of 30? Tan of 30 is 1 over root 3. And same thing for 60. Sine of 60, opposite over hypotenuse, root 3 over 2. Cos, 1 over 2. Tan, root 3 over 1. Boom. So that triangle takes care of both of those. Now for the 0 and 90, that's where this comes in. Because a 0 and a 90 in a 90 triangle doesn't make a lot of sense. So, well, actually it can. You know what? Let's do it that way. Let's do a 0-degree triangle. This is going to be funny and goofy all at the same time. If this is 90 and this is 0 degrees, this also has to be 90. Not much of a triangle, do you agree? Also, this side here, if this is 0 degrees, that must be 0 long. I've just drawn it to make it look like a triangle. This can be whatever I want, 1. If this is 0 degree, this hypotenuse, if it's shrunk down, must be the same as that. And now take a look. What is, sitting here, I'm going to sit at this angle, what is sine of 0 degrees? Sine of 0 degrees is opposite over hypotenuse. 0 over 1 is 0. What's cos of 0? Cos of 0 is adjacent over hypotenuse. 1 over 1, which is 1. And tan of 0 is opposite over adjacent. And that's where you get the 0, 1, 0. For 90, same. You can use the same picture. Because this is the 90 of the 90-degree triangle. I'm going to sit at this other 90. Looking at that, sitting at this 90. What's sine of 90 degrees, which makes no physical sense, but it makes abstract sense, is opposite over hypotenuse. 1 over 1, which is 1. What's cosine of 90? It's adjacent, 0 over 1. And tan, which is really weird, is opposite 1 over adjacent 0. And when you divide by 0, that's impossible. That's why it's undefined or infinity. So that's where this table comes from. That's the quick little description of where and why and how those rules come out of the woodwork. All right, that is it. Over and out.